What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about LabWork 15A. All right, so let's get started. So this is dividing rational expressions, meaning dividing fractions. All right, so you guys all know how to divide fractions, which usually you guys typically say is copy, change, flip, which it is. So let's talk about what we need to do first with these polynomials though. So the first thing we got to do is factor all the tops and all the bottoms. So let's go ahead and factor. Now, this is something that you may need the AC method, and if you do AC method, you might want to do it to the side and then bring those answers back over to the fraction itself, okay? So something to think about there. But the top left-hand corner is going to factor out to be an x plus 2 and x plus 5. The bottom is going to become an x plus 5 times an x plus 5 divided by. The top here is a binomial, and the first step is always GCF, and you guys typically go directly to difference of two squares, which this is not the difference of two squares, but there is a GCF of an x, leaving you an x plus 2. The bottom is going to be x plus 4 times x plus 5. And there we go. All right. So now we would copy, change, flip. So that was the first step right there, is to factor all the top and bottom. The next step is to copy. So let's do this. Copy this fraction right here. So let's go ahead and copy this fraction. Wow. There we go. X plus 2, x plus 5. X plus 5, x plus 5. Change. Division to multiplication, and flip. So we're going to flip this one. So this is going to be a x plus 4, x plus 5 over x times x plus 2. All right. So now with that, we copy, change, flip. We're multiplying fractions. So when we multiply fractions, basically it's all going to be one whole thing, because the top times the top, bottom times the bottom. So the top is going to just be the top. So it's going to be x plus 2, x plus 5, x plus 4, x plus 5. The bottom is going to be x plus 5, x plus 5, and x, which we typically would want to bring to the front, and then an x plus 2. Okay? So when that's the case, now we're going to look at if there's anything on top and bottom that can reduce. So I typically go directly through the top one at a time. So I will say, is there x plus 2 on the bottom? Yes, because x plus 2 over x plus 2 is going to equal to 1. Is there x plus 5? Yes, there is, because x plus 5 over x plus 5 is also equal to 1. Is there x plus 4? No. Is there another x plus 5? Yes, because x plus 5 over x plus 5 is also equal to 1. So in that case, what do we have left? We have x plus 4 over x. And that would be my answer. And that is choice D. There we go. All right, on to number 2. Number 2, we're adding, subtracting rational expressions. But the first thing again is go ahead and factor the tops and bottoms. So we're going to have a 3x over an x plus 1. And typically with the binomials, I like to put parentheses around them. Plus 4 over x minus 1 minus Just gonna have to be longer. longer. It's going to be 6 over x plus 1 times x minus 1, because this is a difference of two squares. Then I tend to ask myself, what did they have that I don't have? So you guys remember, right? What did they have that I don't have? Okay, and this one right here has an x minus 1 that I don't have, and this also has an x minus 1 that I don't have, right? So, with that being said, so this one here needs a x minus 1. The second one needs a x plus 1. So now if you look at it, this has an x plus 1, x minus 1. This has an x minus 1, x plus 1. This has an x plus 1, x minus 1. So they all have the same things. Oops. All right. So what am I doing with those? Well, what I'm actually doing with those is that I'm going to multiply them top and bottom. So I'm going to have a 3x times an x minus 1 over an x plus 1 times the x minus 1. Okay? Then I have a plus. I have the 4 times the x plus 1 over the x minus 1 times the x plus 1 as well. Okay? Minus, and since this is not multiplying anything, it's just going to be as is. There we go. So all three denominators have an x plus 1 and an x minus 1. Awesome. So in order to add fractions or subtract fraction, we add or subtract the top, but keep the bottom. So if I were you, I would rewrite the top with the addition and subtraction signs. So you're going to have a 3x times an x minus 1 plus a 4 times an x plus 1 minus a 6 all over an x plus 1, x minus 1. All right? So let's go ahead and distribute what we need to distribute, because this needs to be distributed. And then this needs to be distributed. Right? Similarly, with the 4 as well. Okay? So, what do we have? We're going to have a 3x squared minus 3x plus 4x plus 4 minus 6 all over x plus 1 times x minus 1. All right. So what do we have here? Let's see. The top has a 3x squared. Let me see. Plus x minus 2 all over x plus 1 times x minus 1. Okay. So you guys could go ahead and factor the top. The question is, are you going to get x plus 1 or x minus 1, right? If not, then I would just say go ahead and leave it alone. But if it does, then I would go ahead and factor it. So if I look at it, a times c is equal to negative 6, while b is equal to 1. So I could do, So I could do, what is it? Negative 2 and positive 3, all right? So let me see here, 3x squared minus 2x plus 3x minus 2. So the first half would have an x, leaving me with 3x minus 2. Ooh, the second one has a what? Has a 1, leaving me with a 3x minus 2. So that does factor, and there is going to be x plus 1 there, all right? So let's go ahead and throw that back up there. And let me see here. So this is going to end up with 3x minus 2 times an x plus 1. All right? All right, so this right here is going to equal to 3x minus 2 times an x plus 1 over an x plus 1 times x minus 1. And we see the x plus 1 over x plus 1 will equal to 1. So what I really have is a 3x minus 2 over an x minus 1. And that, ladies and gentlemen, is choice B. So there is my answer right there. All right, on to the next. Number 3, complex fractions. All right, complex fractions. So I gotta really just focus on just the top, right? And getting that to be a single fraction. So this is the same exact thing as what we just did. So we want to get common denominators. So this one right here is missing an x. This one right here is missing a 49. Okay, so if that's the case, so let's just focus on the top part. Actually, let's do this here. Just so you can see the original here. Okay, so what's the top going to show me? Actually, I'm going to bring it all the way over here. So the top one is going to be x squared over 49x minus a 49 over a 49x. All over. Now, how about the bottom? So what we could do with the bottom is make this one as over 1. Okay, and say, what do they have that I don't have? Well, this is missing an x. Okay, so this one here is going to look like this. It's going to be an x over x plus 7 over x. Okay, so let's go ahead and combine the top together. So the top is x squared minus 49 over 49x all over x plus 7 over x. All right, so now we have this. Now we can copy, change, flip. That's step 3. So we did step 1 and step 2, right? So step 3 now is to copy, change, flip. So this is now going to go this way. So I'm going to copy the top. And over 49 times, that's the change, and the flip of the bottom fraction. So it's going to be x over x plus 7. Okay? Now, what I did just notice is what? That x squared minus 49 is actually the difference of two squares. So that's actually going to be a x minus 7 times x plus 7 times x. So let's go ahead and bring that up to the front. All over. This is going to be a 49 x, forgot the x here, times the x plus 7. So now same thing, we want to see if anything on top and bottom matches. So x over x is equal to 1. X plus 7 over x plus 7 is equal to 1. So what we have left here is this. We got the x minus 7 over just the 49. And that is going to be choice A. And there we go. All right. Number 4, long division. Long division. Woo! Right? So, first thing you would do is write that 4x minus 1 out front. And then I have this division sign. So actually, what I'm going to do, yeah, let's do it that way. All right, so in here, do we need any placeholders? No, because we got 16x cubed plus 12x squared minus 24x plus 14. So the power went from 3 to 2 to 1 to none, okay? So the first thing we ask, so this is step 1, how many times does the first term of the bottom, this is the bottom, go into the first term of the remainder? Well, since we haven't done anything, that is my remainder right now, because that's what's left over, okay, which is the top. So that's what we have. So how many times does that go into it? And typically we do some side work on the side, right? So we would okay, so we got 16x to the third divided by 4x, and I get a 4x squared. So then we bring up here a 4x squared, okay? So from there, we go, okay, so now we're going to take that 4x squared, and we're going to multiply by that 4x minus 1. And we would get a 4x to the third minus a 4x squared. I'm sorry, 16. There we go. So we have 16x to the third minus a 4x squared. And then the next step is that we would flip the signs. So the 16x to the third would become negative, and the 4x squared would become positive, and then we add. And when we add that, the 16x to the third goes away to 0, and we're left with a 16x squared. And then step 4, and then 16x squared, then the last step is to bring down the next term, which is minus 24x. Then we repeat the 4 steps again, okay? So how many times does 4x go into 16x squared? That is the remainder, so that's why we would compare those two first terms. And that is going to be a plus 4x times. So then we multiply, so we get a 16x squared minus a 4x. So what do we have left? We got to flip the sign first, then we add, so I'm going to have a 20x left, and then we have to bring down the next term, which is plus 14. So I ask myself, how many times does 4x go into 20? And that's going to be 5 times. Then we multiply, we get 20x minus 5. Then we flip the sign, and we add. So I have 19 left. Ooh, sorry, let's go backwards here. Hold on. Here's my mistake. when we subtract it, or when we add it, I'm sorry, this is going to become a negative 20. So how many times does 4x go into negative 20x is actually a negative 5 times. There we go. That's better. Now we multiply, and we get negative 20x plus 5. Then we flip the sign, and what we're going to have left is just a 9 left. Okay? So, what's our answer? Our answer is going to be a 4x squared plus 4x minus 5 plus a 9 over a 4x minus 1. And that, ladies and gentlemen, is choice D. So there's my answer right there. All right. Hopefully that helps. Next question. Number 5. All right. So typically this is radical. My index is a 6. So I'm looking for 6 of a kind. Right. So I'll take the 729 and break it down. What goes into 729? Let's see here. I know 2 does not. Let's try 3. It does. 243. What goes into 243? 3 does. 81 times. What goes into 81? 9 does. 9 times. So I got 3, 3, 3, 3, 3, 3. Okay. So this is going to be the 6th root of 3 times 3 times 3 times 3 times 3 times 3 times x times x times x. Since I'm looking for 6 of a kind, right? I got 6 of a kind right here. Right? And that's it. So that gets to come out. And there's not enough x's, so the x to the 3rd stays inside. So the problem is that it wants it to be in, so need to put into rational exponent. Okay? Meaning I need to put this in a power, a fraction power. Okay? So the 3 is fine. The x is the base. But what is the square root? I'm sorry, the 6th root of 3. All right, so remember we did this with the sunshine and the grass and the roots, right? So the root is 6, so that's below the grass, and the 3 is a power, so that's above the grass, is where the sun is. So what does that give me? That gives me a 3x to the 1/2, because it's 3/6 can reduce down to 1/2, so that's going to be choice C. So I got a feeling I'm going to have to do this. That, and say that this is my answer. And there we go. All right, on to the next. All right, here my index is what? Is a 3. Okay, so let's break down 64. I know it's 8 times 8, 2 times 4, 2 times 4, 2, 2 times 2, 2, 2 times 2. All right, so let's go ahead and break this down. Actually, you know what? Let's lay it the other way, the way I like to lay it. So this is the cube root of 2 times 2 times 2 times 2 times 2 times 2. And then I got x times x times x times x, and y times y times y times y times y. And there we go. All right. So again, the index is a 3. So that means I'm looking for 3 of a kind. So there's a 3 of a kind, there's a 3 of a kind, there's a 3 of a kind, and there's a 3 of a kind. So all of those need to come out. So that's going to be a 2 times 2 times x times y. So everything that's highlighted in red should be right there. Okay. Then I have the cube root of what's left. Well, what is left? Well, the x is left and the y squared is left. Okay. So now let's finish writing this. Oh, don't forget the cube root. All right. So I'm going to have a 4xy cube root of xy squared. And that is choice C. There we go. All right. Number 7. Number 7. Okay, so I'm adding radical expressions now. So what I got to do is I got to break down the 63 and break down the 343. But I know that my index is a 2. So I'm looking for pairs, 2 of a kind. So let's go ahead and break down 63. That's what, 7 times 9? 3 times 3. So 7 times 3 times 3, and you can always check it on your calculator too to make sure that 3 times 3 times 7 does give you 63. All right, 343. Let me see here. So this is going to be a 7 times 49. So 7 times 7 times 7 is equal to that. Okay, so what I have here is the square root of 3 times 3 times 7 plus the square root of 7 times 7 times 7. Again, my index is a 2. So therefore, I'm looking for pairs. So if there's a pair and there's a pair. So those come out. So I have a 3 square root of 7 plus a 7 square root of 7. Ooh, they are like radicals. So that can actually add to 10 square root of 7. Yay. And that is going to be choice C. There we go. All right. On to number 8. Ooh, rationalize the denominator. Okay, so in other words, I cannot have a radical in the denominator. So what I need to do is I got to get rid of that. And in order to get rid of that, I'm going to multiply top and bottom by that radical. Okay? And when I do that, what happens is this. The top, the 8 stays alone, stays by itself, but the square root of 2 and the square root of 7 says they're both inside the house. That means what I can do is I can multiply those two. So I'm going to get the square root of 14 all over. Square root of 7 times square root of 7 is just going to be plain old 7. And since nothing else reduces, and I can't break down the square root of 14 anymore, because that's just going to be 2 times 7, then that would be my answer, which is choice A. And there you go. On to number 9. Uh-oh. I'm still rationalizing the denominator, but this is a binomial, right? And typically I like that parentheses around my binomial. So what I gotta multiply by is the conjugate, the 6 plus square root of 10. If I do it to the bottom, I gotta do it to the top. All right, so what do I get? So the top, I actually have to distribute. So I'm gonna get 18 plus a 3 square root of 10 over. The bottom is going to be a 36 minus 10, because negative square root of 10 times a positive square root of 10, negative times positive is going to be negative. Square root of 10 times square root of 10 is actually going to be 10. So that's going to give me 18 plus 3 square root of 10 over 26. Here is something that's going on. Notice that there is a triangle going on, okay? And that triangle means that all three numbers are outside the house, the 18, the 3, and 26. Question is, does something go into all three of them? And the answer is no. So therefore, that is my answer. And that is going to be choice A. There we go. All right, on to number 10, radical equations. All right, so with radical equations, what I want to do is I actually want to get the radical by itself first. All right, so what I'm going to have is this radical. And what I'm going to do is subtract that 6 over to the other side, so it's going to be equal to negative 6. Okay? Now, from here, you should already know that there's no solution. But let's say that you don't recognize that, which is certainly fine, that I continue on, which would be good for you to see for other problems anyways. So let's go ahead and do that. All right, so the opposite of square root is what? Is squaring. So if I was to get rid of this radical, or the square root, I would square it. So square both sides. So what I'm going to get now is a 4x plus 8 is equal to a 36. Because the square root and the squared are opposite operations, so they cancel each other out. That's why I only have a 4x plus 8 left. All right, and then negative 6 squared is going to be positive 36. So now I'm going to subtract the 8 over. So I get 4x is equal to 28. So x is going to equal to 7. All right, now radical equations are the ones that you actually have to check the answers. Okay, so let's say, for example, let's make this, I don't know, green. Okay, so let's check this answer. All right, so square root of 4 times 7 plus 8 plus 6, is that equal to 0? So this is going to be 28 plus 8. Is that equal to 0? So is the square root of 36 plus 6 equal to 0? Is 6 plus 6 equal to 0? No. Okay? So since that's a no, this is going to be we're going to have to reject this particular answer. So therefore my answer, since there's no other choices as an answer, would be no solution, which is choice A. And there you go for the answer. And there you go. All right. If you have any questions, let me know. Talk to you later. See ya. Bye.